Welcome back to my class in Trigonometry. Today we will take up angles of elevation and depression. We start with angle of elevation. The angle of elevation is defined as the angle that the line of sight of the observer makes with the horizontal. The angle of elevation of the object at which the observer is looking up is the angle that the line of sight of the observer makes with the horizontal. Suppose this is the observer, and the observer is looking up at some object. The observer is standing on a flat horizontal surface, and the object is directly above, the object is above the observer, above the horizontal surface, and the observer is looking up at the object. And this line from the eye of the observer to the object is the line of sight of the observer. From the eye of the observer, we construct a line parallel with the horizontal surface. And the angle of elevation is defined as the angle, this angle, that the line of sight of the observer makes with the horizontal. This is the angle of elevation. The angle of elevation of the object. It's the angle that the line of sight of the observer makes with the horizontal. Now we define angle of depression. The angle of depression from an object is, from the observer to an object is defined as the angle that the line of sight of the observer makes with the horizontal. We consider again an observer. And suppose this observer is looking down at some object. This is the object. The observer is looking down at this object. And the line from the eye of the observer to the object is the line of sight. Line of sight of the observer. Now, the angle of depression from the observer to the object is the angle that the line of sight of the observer makes with the horizontal. This is the horizontal surface on which the observer is standing on. And from the eye of the observer, we draw a line parallel with the horizontal surface. Now, this angle this is the line of sight. Again, this is the observer looking down at some object on the horizontal surface, on a flat surface on which the observer is also standing on. And the line from the eye of the observer to the object is the line of sight of the observer. And the angle of depression from the observer's eye to the object is the angle that the line of sight of the observer makes with the horizontal. From the eye of the observer, we draw a line, which is this line, parallel with the horizontal surface on which we find the object and on which the observer is standing on. And this angle is called the angle of depression. The angle of depression from the eye of the observer. Now, if we construct a line from this object to straight to the observer, you can see that this line and this line are parallel. This is the horizontal surface and this line is parallel with the horizontal surface. Hence, these lines are parallel. And this line of sight of the observer, from the observer to the object, is a transversal of these parallel lines. Hence, this angle and this angle. This angle and this angle are congruent angles, which means that they have the same measure. And that's one of the properties of parallel lines that are cut by a transversal. The alternate interior angles are congruent. This angle and this angle are alternate interior angles. Alternate because they lie on opposite sides of the transversal, and interior because these angles are between the parallel lines. And a theorem from your geometry, high school geometry, says that the alternate interior angles are congruent if two parallel lines are cut by a transversal. Similarly, if we construct a line from the object parallel with this horizontal surface or this line, these lines are parallel, and this line of sight from the observer to the object is a transversal because it cuts these parallel lines. Now, this angle of elevation of the object is also equal to this angle. This angle of elevation is also equal to this angle. Again, by property of parallel lines cut by a transversal, the alternate interior angles are congruent. This angle and this angle are alternate because they lie on opposite sides of the transversal line. And they are interior because they are between the parallel lines, and they are congruent. Now we will have some word problems that involve angle of elevation and angle of depression. For our first example, consider the following problem. A woman who is 1.75 meters tall stands on horizontal ground 28 meters from a tree. The angle of elevation of the top of the tree from her eye is 32 degrees. What is the approximate height of the tree? Now, in solving word problems, in solving many word problems, drawing the diagram would help in solving for the unknown or for the required quantity. And in the diagram we specify, we indicate the information given from the problem. And here there is a woman who is 1.75 meters tall, standing on horizontal ground. We take this as the horizontal ground, and if there is a woman standing, the height of the woman standing on the horizontal ground is 1.75 meters. And the woman standing on the horizontal ground is 28 meters from a tree. From this position of the woman, she is 28 meters from the tree. Suppose this is the tree. And the distance of the woman from the tree is 28 meters. These are the first two given. The height of the woman standing on horizontal surface or horizontal ground is 1.75 meters. And the distance from the position of the woman to the tree is 28 meters. The next sentence says the angle of elevation of the top of the tree. We take this as the top of the tree. From her eye is 32 degrees. We take this point as the eye of the woman looking at the top of the tree. And the angle of elevation of the top of the tree from her eye is 32 degrees. Hence, this is the line of sight of the woman from her eye to the top of the tree. And to draw the angle of elevation of 32 degrees of the top of the tree from the eye of the woman, we construct a line from the eye of the woman parallel with the horizontal ground. Now, the angle of elevation is the angle, this angle, that the line of sight of the woman makes with the horizontal, makes with this line, horizontal line parallel with the horizontal ground. And this angle of elevation of the top of the tree from the eye of the woman is 32 degrees. And the question is, what is the approximate height of the tree? The height of the tree is the distance from the top of the tree to the level ground or the horizontal ground. And we denote that height by h. We denote the distance of the, we denote the height of the tree by h. It is the distance from the top of the tree to the level ground or horizontal ground. And the tree is standing perpendicular with the horizontal ground. So this angle is 90 degrees. This is 90 degrees, and we have constructed a right triangle with the right angle at this point. You can see that the height of the tree is equal to this distance, which is 1.75 meters, plus this distance. And from the diagram, this length is equal to this length, which is h, minus this length, which is 1.75 meters. Again, this length, this side of the right triangle is equal to this whole length, the height of the tree, minus this length, which is 1.75 meters. H minus 1.75. And this side adjacent to 32 is 28 meters. Hence, we are given the side adjacent to 32, 28 meters, and the height that we want is contained in the side opposite 32 degrees. And the trigonometric function that contains this side opposite 32 degrees and this side adjacent to 32 degrees is tangent. Therefore, we use tangent of 32 degrees. Tangent of 32. The tangent of 32 degrees is equal to the ratio of the opposite side and the adjacent side, or tangent of 32 degrees, or tangent of 32 degrees is equal to opposite. The side opposite 32 is this side, which we have shown, whose length is h minus 1.75. Divide by adjacent, the side adjacent to 32, or the side of the right triangle that makes the acute angle 32 degrees has a length of 28 meters. This side of the right triangle adjacent to 32 is 28 meters. And from this equation, we solve for h, multiply 28 by tangent of 32. 28 times tangent of 32 degrees equals h minus 1.75. And finally, to solve for h, we transpose negative 1.75 to the left-hand side. Therefore, h equals 28 times tangent of 32 degrees. And we transpose negative 1.75 to the left side. We take the opposite side. And we have plus 1.75. And we compute this using your scientific calculator. And the mode should be in degree. Okay, we start with 28. 28 multiplied by tangent of 32 degrees plus 1.75. And you should get 19.246. 19.246 34185. From your calculator, you can round off directly your final answer to 2 decimal places. The digit to be rounded up is the third digit from the decimal point. If you want your answer to 2 decimal places, the third digit from the decimal point is to be rounded off. So from the decimal point, we count 3, 1, 2, 3, and 6 is the number to be rounded off. Since 6 is more than 5, we add 1 to the preceding digit 4. And so the final h, the final value of h is 19.25 meters. The height of the tree is 19.25 meters. For our second example, consider the following problem. A man 2 meters tall, standing on top of a cliff, spots a house in the adjacent valley at an angle of depression of 17 degrees. The cliff is 56 meters tall. How far is the house from the base of the cliff? Again, we'll draw the diagram and to facilitate our solution, and we indicate in the diagram the information given in the problem. We start with the cliff. Suppose this is the cliff, and the cliff is 60 meters. A man is standing on the top of the cliff, and the man is 2 meters tall. And we take this point as the eye of the man. And from this position of the man, he spots a house in the adjacent valley at an angle of depression of 17 degrees. Suppose the house is to the left of the cliff. We take this point as the location of the house spotted by the man. And from the eye of the man, the angle of depression of the house is the angle that the line of sight from the eye of the observer to the house. We construct this line as the line of sight from the eye of the man to the house. And the angle of depression is the angle that this line of sight makes with the horizontal. From the eye of the man, we construct a horizontal line parallel with the level ground on which both the cliff and the house are on. We draw this line, horizontal line, from the eye of the observer and parallel with the level ground. And this angle is 17 degrees. That's the angle of depression of the house from the eye of the observer, who is 2 meters tall and standing on top of the cliff that is 60 meters tall. And the question is, how far is the house from the base of the cliff? This is the base of the cliff, and we want the distance of the house from the base of the cliff. We denote this distance by D. And this is a right angle. The cliff is standing perpendicular to the level ground. And you can see that from this diagram that this angle 17 degrees is equal to this angle, because these lines are parallel and this line of sight is the transversal line of these parallel lines. Hence, by a theorem from your high school geometry, the alternate interior angles are congruent. This is 17 degrees, the angle on the opposite side, on the other side of the transversal is also 17 degrees. Now, the total distance from this point, from the eye of the observer to the base of the cliff is 2. The height of the man plus the height of the cliff is 2 plus 60, 62 meters. is height of the right triangle. This side of the right triangle opposite 17 degrees equals 2 plus 60 or 62 meters. And the unknown, the required quantity, the distance of the house from the base of the cliff is the side adjacent to 17 degrees. Hence, based from this information given, we have to use tangent of 17 degrees because the tangent, trigonometric function tangent, includes the sides opposite the given acute angle 17 degrees and the side adjacent to acute angle 17 degrees. Hence, we use tangent of 17 degrees. Tangent is defined as the ratio. The value of the tangent of an acute angle is equal to the ratio of the opposite side to the adjacent side. From our diagram, the side opposite 17 degrees has a length of 62 meters. And the side adjacent to 17 is D, which is the required. And from this equation, we solve for D. First, multiply D by tangent of 17 degrees. D times tangent of 17 degrees equals 62. Finally, we divide both sides by tangent of 17 degrees so that we are left with D at the left-hand side of the equation. We divide the left side by tangent of 17 degrees. And we divide the other side by tangent of 17 degrees. Hence, the required distance from the house to the base of the tree is 62 divided by tangent of 17 degrees. Again, you get your calculator to compute for the value of 62. The mode should be in degree. 62 divided by tangent of 17 degrees. And you should get 202.7928. The answer is non-repeating, non-terminating decimal number, but we give the final answer to 2 decimal places, and the third digit from the decimal point is to be rounded off. From the decimal point, the third digit is 1, 2, 3, 2. 2 is the number to be rounded off, but 2 is less than 5. Thus, we simply drop 2 and all the digits to its right. And the distance of the house from the base of the cliff to 2 decimal places is 202.79 meters. The distance of the house from the base of the cliff is approximately 202.79 meters. For our third and last example, consider the following problem. 2 buildings are across the street from each other, 29 meters apart. From a point on the roof of one building, the angle of elevation at the top of the other building is 23.5 degrees. And the angle of depression of the base of the other building is 32 degrees. How tall are the buildings? The two buildings are definitely standing on a horizontal ground, and there are two buildings and the problem says that these two buildings are across each other, across the street from each other. This is the street, and this building is just across this street, this building from the street, and this building is across this building in this same street. These two buildings are across each other in this street, and they are 29 meters apart. From a point on the roof of one building, the angle of elevation at the top of the other building. Now, because there is an angle of elevation from one building to the top of the other building, one building is, the problem implies that one building is taller than the other building. Because from the top of one building, we take this as the first building. There is an angle of elevation from the roof of the first building to the top of the second building. And that angle of elevation is 23.5 degrees. From the roof of the first building to the top of the other building, we take the second building as the other building that is referred in the problem. From the roof of the one building to the top of the other building, this second building, the angle of elevation is 23 degrees. And this angle of elevation is the angle that this line makes with the horizontal. So from the roof of the first building, we draw a line perpendicular to the second building and parallel to the level ground. And this is the angle of elevation, 23.5 degrees. degrees is the angle of elevation. The angle that this line from the roof of the first building to the top of the second building makes with the horizontal. And from the roof of one building, the sentence continues. From a point on the roof of one building, the angle of depression of the base of the other building, we are still here. On the roof of the first building, the angle of depression of the base of the other building. The other building here is this building, our second building. From the roof of the first building to the base of the other building, this second building, the angle of depression is 32 degrees. And the angle of depression is the angle that this line from the roof of the first building to the base of the other building or second building makes with the horizontal. And this angle is 32 degrees. The distance between the two buildings that are across from each other. is 29 meters. Question: how tall are the buildings? We denote the height of the shorter building as x, and we denote the height of the taller building from the top of the second building to its base by y. And these are the unknown. And we can start by finding x, the height of this first building. We have a right triangle. This is a right angle. And this right angle because the building is standing perpendicular to the level ground. Now, this angle is also 32 degrees. Because this angle and this angle are alternate interior angles. These lines are parallel and this line is the transversal line. And by property of parallel lines cut by a transversal, alternate interior angles are congruent, which means their measures are equal. Now the side opposite 32 is x, the height we want, the height of the first building. And the given is the side adjacent to 32 degrees. Therefore, to find x, we use the trigonometric function that involves opposite and adjacent sides. And that's tangent of 32 degrees. Tangent of 32. Tangent of an acute angle is equal to the ratio of the opposite to the adjacent side. Or tangent of 32 degrees. The side opposite 32 degrees is x. And the side adjacent to 32 degrees, the side of this right triangle that makes 32 degrees with the hypotenuse, its length is this side, adjacent side with a length of 29 meters. And from this equation, we find x by multiplying 29 by tangent of 32 degrees. We have 29 multiplied by tangent of 32 degrees. We find that by using our calculator, the mode should be in degrees. 29 multiplied by tangent of 32 degrees. And you should get 18.12. The third digit from the decimal point is 1, and it's less than 5. So we simply drop that digit and all the digits to its right. And to 2 decimal places, the final answer is 18.12 meters. That's the height of the first building. Now, we find the height of the taller building, which is y. And you can see that this height of the taller building is equal to this. Y is equal to this, which is x. And this side of this right triangle opposite 23.5 degrees. And this side this side opposite 23.5 degrees is equal to y from the top to the base minus x. This is y minus x. And x is 18.12 meters. And this side adjacent to 23.5 is also 29 meters. Now we find y using this right triangle and the tangent of the acute angle 23.5 degrees. Tangent of 23.5 degrees equals opposite tangent of an angle, acute angle is equal to the ratio of the opposite side and the side adjacent to 23.5 degrees. Or tangent of 23.5 degrees equals the side opposite 23.5 degrees. This is 23.5 degrees. The side opposite is y minus x. And the adjacent is the side adjacent to 23.5 is this side, which is equal to 29 meters. We multiply 29 by tangent of 23.5. 29 times tangent of 23.5. And at the right hand side, we replace x with its value, 18.12 meters. Y minus 18.12. And we solve for y from this equation by transposing negative 18.12 to the left. At the right, we get y equals 29 times tangent of 23.5 degrees. Transpose negative 18.12 to the left, we get plus 18.12. And we find y, this sum using calculator. Excuse me. 29 multiplied by tangent of 23.5 plus 18.12. And you should get 30.7295588. The answer is non-terminating, non-repeating decimal number. And we round up the final answer to 2 decimal places. The third digit from the decimal point is to be rounded off. And that digit is 9. You count 3 from the decimal point, 1, 2, 3. The third digit from the decimal point is 9. And it's more than 5, so we add 1 to the preceding digit, 2. And the final answer should be 30.73 meters. 30.72 meters. The shorter building has a height of x, 18.12 meters. And the taller building has a height of y equal to 30.72 meters. Thus, the buildings are 18.12 meters and 30.72 meters tall. your practice, please do the following exercises. Number 1, a man is 1.94 meters. He stands on a horizontal ground, 72.3 meters from a building. The angle of elevation of the roof of the building from his eye is 34.6 degrees. How tall is the building? For you to be able to check your answer, I have given you the answer for this problem. 51.83 meters is the height of the building. But when you show your solution, show your diagram and indicate the given information in your diagram. Number 2, a scientist standing on top of a building spots a track on the ground at an angle of depression of 27 degrees. The building is 123 meters tall. How far is the track from the base of the building? Again, for you to check your answer, I give you the answer for this problem number 2. The track is 241.40 meters from the base of the building. The answer here is up to 2 decimal places, hence we cannot drop 0 because 0 is significant. Problem number 3, Hotel X and Hotel Y are across the street from each other, 59 meters apart. The two buildings are 59 meters apart, and Hotel X is across Hotel Y on that street, and Hotel Y is across Hotel X. They are across the street from each other and they are 59 meters apart. That is, the street is 59 meters wide. From a point on the roof of Hotel X, the angle of elevation at the top of Hotel Y is 29.7 degrees, and the angle of depression of the base of Hotel Y is 38.5 degrees. What are the heights of the hotels? This problem number 3 is similar to my example number 3 that involves both angle of elevation and angle of depression. And for you to check your answers, I give you the answers for problem number 3. The hotels are 46.93 meters and 80.58 meters tall. If you have questions about the lesson today, you ask your questions in the comments below. And do not forget to subscribe or ask your friends to subscribe to my YouTube channel, Art Kalisan. Thank you for joining me in my class today.